there, in this video we're going to go over division of polynomials, but I'll start with reminding ourselves what does long division look like with numbers. So if I ask you to divide 35 by 4, 35 is what we call the dividend. So some terminology here, and 4 is the divisor. So when it's written in fraction notation like this, then the denominator is the divisor. So when you're dividing, you're trying to see, does 4 go into your dividend, right? Does your divisor go into your dividend evenly? If it does, we're going to get a remainder of 0. If it doesn't, like in this case, 35 is not a multiple of 4, so we are going to get a remainder. And our remainder should be either 1, 2, or 3. You can't get a remainder of 4 because 4 can be divided by 4. So let's try it. So 35 divided by 4. So we do our little box here. The divisor goes on the outside, so I'm going to put 4 there. And the dividend goes on the inside. And then you usually check, right? Does 4 going to 3, the tens digit here? No, it doesn't. So you take it as a double digit number of 35. Does 4 go into 35? Yes. And it goes in 8 times. So we line up the quotient. This is what's up here is going to be, is what we call the quotient, with the place value where it actually did go in. So, right, 4 doesn't go into 3, so we go take the 5 with it. So 4 goes into 35 8 times. And so we line up the 8 with the 5 there. 8 times 4 is 32. And with division like this, we subtract, and 35 minus 32 is 3. And now 3 does not go into 4. So this is our remainder, with an A there. Sometimes I see people spell a reminder, and no, it's the remainder. So what's left over. And so how do you write your final answer? So we say 35 then divided by 4 is equal to 8, and we have a remainder of 3. How do you write the remainder? We say plus 3 fourths, right? There are 3 out of 4 left over. And so how do you check your answer to make sure you did the division correctly? Remember, division is the opposite of multiplication, so we can check it with a multiplication problem. So to check, I essentially do my divisor times the quotient. So 8 times 4. So the quotient times the divisor, 8 times 4, plus the remainder. So quotient times the divisor plus the remainder should equal the dividend. So when I do 8 times 4, that's 32 plus 3, that is 35. So that checks. So we did our division, right? So now what does that look like with polynomials? So I have an example here. With polynomials, we want to divide this quadratic divided by this linear. Now remember, x stands for a number, so x can be anything. So let me just make this a little bit bigger. So for example, what if x was 3? If x was 3, notice that this fraction is going to become 2 times 3 squared plus 4 times 3 plus 5 over 3 plus 1. So we end up with 2 times 3 squared is 9, so 2 times 9 is 18. 4 times 3 is 12, and plus 5 over 4. So 18 plus 12 is 30, plus 5 is 35 over 4, which is the division problem we did up there. So this division of polynomials, when x is 3, we get the exact same division problem from above. But let's try and write x can be any number. Well, not any number, except x can't be -1, because then -1 plus 1 will give us 0 in the denominator, which we can't have. But other than -1, x can be anything. So this can represent any number of different fractions. So let's do the long division with the polynomial. So we're going to do the same thing we did with the 35 over 4. So I'm going to draw my division box, And the divisor, x plus 1, goes on the outside. The dividend, right, the numerator, 2x squared plus 4x plus 5, goes on the inside. And now, just as we did before, right, we were asking, does 4 go into 3? And it didn't. So here we're going to go, so we took it as 4 going to 35. So here I'm going to ask myself, does x, so we cannot do it term by term, does x go into 2x squared? And then how many times? So there are different ways that you can think about this. So one way is, what do you multiply x by to get 2x squared? And another way you can think of it is just take the leading term of the dividend, so 2x squared, and divide it by the leading term of your divisor. Right, and so what does this reduce to? That will be 2x. So what do I multiply x by to get 2x squared? It will be 2x. And just as we did before, we're going to line them up. In this case, for polynomials, we're lining them up by degree. And now I multiply. So 2x times x is 2x squared, and 2x times 1 is 2x. And just as we did before, we subtract. So here we're going to have to distribute the negative, so that's going to become a negative. So 2x squared minus 2x squared, that's going to cancel out. So these cancel out. And then 4x minus, because we're distributing that minus, 4x minus 2x is 2x. And I bring down the 5. And so now we're going to do it again. So I'm going to get rid of these arrows. And we're going to do it again for 2x. So looking at my leading term of the divisor, what do I multiply x by to get 2x? Or you can think of taking the leading term of the dividend now. My dividend is now 2x plus 5. And the leading term of the divisor, 2x divided by x, is 2. So what do I multiply x by to get 2x? 2. And notice that they're lining up. Linear on top of linear, constant on top of constant. And so we do it again. 2 times x is 2x. And 2 times 1 is plus 2. And just as before, we subtract. So distribute your negative. Those cancel. And negative times a positive 2 becomes a minus 2. And so we're left with 5 minus 2 is 3. And now I can't keep going on, right? This is a linear, my divisor is a linear polynomial, right? Degree 1. And this is a constant term, degree 0. So as soon as my degree, the degree here is smaller than the degree of the divisor, we can stop. So this 3 becomes my remainder. Which notice that it makes sense because when we did it with numbers, the remainder was 3. So regardless of the value of x, what it's looking like is that our remainder is always going to be 3. And so how do we check it? Well, let's write out what the answer will be. So therefore, the little 3 dots is therefore 2x squared plus 4x plus 5 divided by x plus 1 is equal to the quotient. Remember, the quotient is the quantity that shows up here. So the quotient is 2x plus 2. So 2x plus 2 plus the remainder. Just as we did with numbers, the remainder is the remainder divided by the divisor, x plus 1. And again, let's do a quick check. When x is 3, what do you get? When x equals 3, remember this fraction polynomial was 35 over 4. And so now check this out. If you put in 3 in here, 2 times 3 is 6. So you'll have 2 times 3 plus 2 plus 3 over 3 plus 1. 2 times 3 is 6 plus 2 is 8. So you get 8 plus 3/4, which is exactly what we got when we did the 35 over 4 division up here. But now this is just a regular polynomial. And just as with numbers, to check your answer, you will multiply your divisor times the quotient. So the quotient times the divisor plus the remainder needs to equal the dividend. If that doesn't occur, then that means you've done something wrong in your division. So let's see, the quotient is 2x plus 2. So I'm going to have 2x plus 2 times the divisor, x plus 1, plus the remainder. The remainder is just the number 3. Right? This is my remainder. So when I say plus the remainder, it's just the 3. When we write the answer, the quotient, right, this is the remainder divided by the divisor. So be careful to not think the remainder is the whole 3 over x plus 1. The remainder is just the result, the leftover after the whole long division is done. So here, let's multiply this out. Do a little FOIL. So you're going to have 2x squared plus 2x plus another 2x, so plus 4x, and then plus 2 plus the remainder, 3. So what does this equal? Combine like terms. So you get 2x squared plus 4x plus 5. Is this the dividend? And the dividend is the numerator of our fraction. Yep, 2x squared plus 4x plus 5. So we did the long division correctly. So let's try another example. So in this next example, let's divide x cubed plus 2x squared minus x plus 1 into x plus 3. So we're going to draw our division box. The divisor is the denominator, so x plus 3 goes on the outside. The dividend, the stuff in the numerator, goes on the inside. And now we do the same thing we did above. So how many times, what do I multiply x by to get x cubed? To get x cubed, x times what gives you x cubed? That will be x squared. And again, another thing you can do is take that leading term, the x cubed, and divide it by the leading term of your divisor. X cubed divided by x is x squared. So that's what goes here, and line them up by degree. And I multiply. So x squared times x is x cubed. We want these, the leading ones, to match up so that then when we subtract, they cancel. And then x squared times 3 is plus 3x squared. And just as with any long division problem, we subtract. So when you subtract, what happens? Then we get x cubed minus x cubed. These cancel. Distribute your negative. So that becomes a minus 3x squared. So I'm left with 2x squared minus 3x squared. That's negative 1x squared. So negative x squared. And now bring your other terms down. So minus x. I tend to like to bring everything down so that I don't forget that I have stuff up there. So now let's keep going. And let me erase these arrows as we move on to the next term. So now I have a negative x squared as my leading term. So what do we multiply x by to get negative x squared? And again, what you can do is take the leading term of this, so negative x squared, and divide it by the leading term of your divisor, divided by x. And that gives you negative x. So what do I multiply x by to get negative x squared? Negative x. And notice that they're lining up by degrees. And so we do it again. So negative x times x is negative x squared. I want those to match up. Negative x times positive 3 is minus 3x. And we subtract. So minus and minus becomes a plus, so those cancel. And minus and minus here becomes a plus. So negative x plus 3x gives me 2x. And bring down the 1. And the degrees are the same, so I can keep going. Right? I stop once a degree is smaller than the divisor. So now, what do I multiply x by to get 2x? And that should be 2. And again, you can do the same thing. The leading A term here is 2x. The leading term of our divisor is x, so you'll get a 2. So plus 2, and you do it all over again. So 2 times x is 2x, and 2 times 3 is 6. And as always, with long division, you subtract. And the main thing here is going to be that you're really careful to not forget to distribute that negative. So negative 2x, those cancel, and negative times a positive becomes negative 6. And so 1 minus 6 is negative 5. And so this is our remainder. So how do we write our answer? So the division problem is going to be x cubed plus 2x squared minus x plus 1 divided by x plus 3, that was what we divided, is equal to the quotient. The quotient is what we get on top of the bar here. So I'm going to highlight it. So this is the quotient. So I'm going to get the quotient x squared minus x plus 2, and then the remainder. So we have minus 5 left over from x plus 3. So it'll be minus 5 over x plus 3. Right? So the format of your answer is the quotient plus the remainder divided by the divisor. Right? The remainder, again, is just the thing that you're left over with at the end of your division problem, not once you put it with the divisor. So be careful about that. So let's try another example. And how about you try it on your own, and I'm going to do the solution to this example in another video. So let's divide x to the fourth minus 3x cubed plus x minus 2 all over x squared minus 5x plus 1. So try it, see what you come up with, but I will do the solution in the next video, part 2 of long division.